if we were able to cut the Earth in half and see its layers, what you would see are a crust which is very thin. If you think about the peel of an apple, how that compares to the size of the rest of the apple, that's about how thin the crust is. Then we have the mantle underneath that, and at the very center of the Earth, the core. Looking at just the crust, there's two different types. The oceanic crust is a little bit thinner. It's only about 3 to 4 miles thick. It's made of basalt, which is a more dense type of rock. So it sits a little bit below the continental crust because of its density. Continental crust is thicker but less dense because it's made mainly of granite. It's about 20 to 30 miles thick. All right, so going back to our Earth's interior, we can actually divide the mantle into two parts. So let's go ahead and do that. We have the upper mantle, which is cooler and a little bit more brittle, which means the rocks will break easier. And then we have the lower mantle. Lower mantle is warmer, so the rocks are soft, if you can imagine a soft rock. Similar to the property of silly putty. Silly putty is a solid, but we can mold it and bend it. Because of the temperature here, these rocks can move and almost flow. They aren't liquid or molten like parts of the core. If you look at the core also can be divided into two parts. We can divide it into the inner core and the outer core. The outer core is molten or liquid. It's made mainly of iron and nickel. It's the most dense layer, which is when the Earth was originally formed and it was liquid, the dense material sank to the center. So it's this liquid outer core. It's liquid because of the high temperatures.
I can't do this.
All right, the inner core is actually solid. It's at the same high temperature, the outer core, but it remains solid because of the pressure. You've got the weight of the rest of the Earth pushing down, so the inner core remains solid. So we have a solid, almost iron-nickel core, similar to what you would find in a meteorite. Now this core produces heat that radiates towards the surface. So it creates convection currents. Convection is where heat rises, and then the cooler material sinks to the bottom. And so that's happening all around the Earth. So these convection currents actually cause the crust in the upper part of the mantle to move. We can divide the crust and upper mantle into plates. There's seven major plates. But the crust and upper part of the upper mantle is known as the lithosphere. So let's do this. Litho means rock or solid, so that's the solid part of the crust in the upper mantle. Remember that as you go down within the Earth, the temperature increases. So this lower part of the upper mantle is known as the asthenosphere. And the asthenosphere is a little bit softer, which allows those brittle plates to slide across the rest of the mantle. And we're going to look at what happens where you have these convection cells that diverge, and when you have these convection cells that converge. We're going to see different types of plate movements that you'll see in the next few video clips.